Hi guys, in this video we're going to have a look at vectors. So vectors, I've split this up into 3 videos. This is the first one where we're just going to talk about the basics, about what a vector actually is, and have a look at some of the more basic stuff to do with vectors. And then video 2, we're going to look at vectors with geometry, so within shapes. And then the third and final video will be looking at how to prove certain vectors are parallel or on a straight line. So as I said, this one is just to do with the basics. So here we go then. So a vector has both magnitude, so like a size, and direction. So a classic example of this might be if you are to kick a football, how fast it's going would be the magnitude, and obviously which direction it goes would be the direction. You probably have also seen vectors when looking at transformations, more specifically translation, when we talk about moving a shape up, down, left or right, because we use column vectors. And that's exactly what we're going to be doing now in our first example here. So hopefully this isn't too unfamiliar. So here we have a vector called A, and you notice there's an arrow. So this is the direction we're going from this point to this point. Okay, and we write this as a column vector, so hopefully this will look familiar, where the top number is the x value, so left or right, and the bottom one here is y, and that's your up or down. So if I have a look at this one, starting from here going to here, I go 3 to the right, so 3 goes on top, and then I go 2 up. So we say the vector A is actually 3, 2. Let's have a go at B then. Exactly the same thing. I'm going from this point, there's the arrow to that point. So I'm going across 2. And then I'm going up 3. Like so. Okay. And this one here, I'm going from this point to this point because there's the arrow there. So this time I'm looking at vector C. So I always go along the corridor first. So that's 1, 2, 3, 4. And then 3 down this time. If I'm going down, it's a -3. And this one here, so vector D, I'm not going left or right at all. So in fact, in this case, that's a 0. But I am going down 4. So just like over here, if I'm going down, we say -4. So that's the basics. And hopefully that is a little refresher from when you did translation. This one here. Now, I've done this one deliberately because we need to go left -3. So because it's left, we say it's -3. And we're then going down 2. So down is -2. So remember, going to the right, positive, left, negative, up, positive, down, negative. And you might notice it's exactly the same as this. Well, nearly exactly the same. The magnitude, the size, is exactly the same, but the direction is different. And if you look at the actual vector itself of 3, 2 for A, we've actually made everything negative, so -3, -2. So to label this, we actually say that's -A. So if it's exactly the same but you change direction, if that's vector A going that way, going the opposite way, we say is -A. So if you go in the opposite direction, you just make that a negative like so. And it's easy to see when you see 3, 2, -3, -2. It's obvious why we call it -A. You can also do scale factors. So here, I'm going to draw 3B. So if B here was 2, 3, and then I want 3B, all I do is I times everything by 3. So 3 times 2 would be 6, and 3 times 3 would be 9. So that would be what it would be if you were to just write it down. And of course, if you were to draw it, I'm hoping this fits. Let's say I'll start from this point here. I go 6 across, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Am I going to miss it? Yes, I am. Good times. So if you were to draw it, obviously that would be it. And don't forget to draw the arrow, because B is in that direction, which means 3B must also be in that direction. And of course we could label that 3B there as well. And a quick point, which does come in handy when we start talking about parallel lines, when it's a scale factor, so b and then a scale factor 3b, these lines are parallel because they're just a scale factor. This one is just 3 times bigger than this one, and that's a way of showing that they're parallel, which does come in handy, as I say, in my third video. And 2c, exactly the same thing. I have 2, and then c has the vector 4 minus 3, and I just do 2 times 4, which is 8, 2 times minus 3, which is minus 6, and again we can draw that. So I start here, 1, 2, 3, 4, 5, 6, 7, 8 across. Oh, no, I'm being silly, I need to go 6 down, don't I? Sorry, let's move that point to there. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6 down. There we go. So yeah, always be careful. You need to get the direction going right. So I'm going from that point to that point. So 8 to the right and 6 down. So you can also draw it there as well. Okay, so that's some of the basics. Let's have a look at some more. Right, so you've had a look at scale factors, so you can times them by 3 or by 2 or by minus 3 or by minus 4 or something like that. But what happens when we add them together? So let's have a look. So here's my vector A, and I'm just going to write that down. So 3 across, 3 up, so that's what A is. And B is 4 across and 1 up, so 4, 1. And I want to know what A plus B is. Well, here's A. Now if I add B to it, I can draw that. Let's have a look what it looks like. So 1, 2, 3, 4, and then 1 up. So it needs to go there. And draw my direction, and that's B. So a couple of ways. Let's have a look. So we've got 3 and 3 for A. So 3, 3, and then plus B. And B we said was 4 and 1. And then just add the tops and add the bottoms. So 3 add 4 is 7. 3 add 1 is 4. So the vector of A plus B is just 7, 4. And because I've drawn this, we can actually test it. So notice I'm at this point here. I go along A that way, then I go along B this way. So 1, 2, 3, 4, 5, 6, 7 across. 1, 2, 3, 4 up. So you can see I can just very simply add the vectors here to find out what the overall resultant vector would be when I add those two together. And you can see if I start at that point there and that point there, I go 7 across, 4 up, it works. Sorry, slight edit here guys. I forgot to do this when I did this the first playthrough, so just slotted it in now. So we had A plus B, which is obviously was this. Just to prove, you can do it the other way around, and it doesn't actually make any difference whatsoever. So I can have 4, 1, plus 3, 3, which is A, and I can add those together. 4 add 3 is 7, and then 1 add 3 is 4. Okay, and if you were to draw that, you would have your B, which would be like that, flowing that way. So that's my B, and then I'd have my A, 1, 2, 3, 1, 2, 3, which would be there, flowing that way in that direction. And again, if you was to work it out, 1, 2, 3, 4, 5, 6, 7 across, 1, 2, 3, 4 up. So again, either way round, it doesn't matter, you get the same. So that was just a very quick slight edit onto that one. When you take away, it's slightly different. Only be a little bit different though. So here's my P, which is 2 across and 4 up. And there's Q. So 3 across and 1 up. But we take Q away. So remember what I said, if you want to go negative, it stays exactly the same, but you change direction. So if I change this, Q is that way, so minus Q is going that way. Now, if I'm to draw that, people will want to draw that on the end here. But the problem with that is that's Q, which would be fine, but we need minus Q, so I can't actually do that. So let's assume it's minus Q, and I put minus Q there, which is going the other direction like that. Drawing it, this doesn't work because I'm going this way, and I need to go across to Q, but I can't because Q is going this way. So in fact, you can't draw it like that. Best way is this way, is draw it here, like so. So the arrow is facing that way, and that's minus Q. So I can flow. I can go across P, and then I can go down this minus Q like so. And let's have a look what that looks like. Or I should do this. So minus Q, starting from this point to this point, would be minus 3, minus 1, left 3, down 1. So P is 2, 4. And I'm taking away Q, so taking away 3, 1. So 2 minus 3 leaves me with minus 1. And then 4, take away 1 is 3. Let's have a look. If I'm starting at this point here, minus 1 to the left, up 3, so that works. What happens if you just use minus Q straight away? So in other words, if you do 2, 4, which is P, and then you add minus Q, because you've already got minus Q, which would be minus 3, minus 1. As you can see, 2 plus minus 3 is still minus 1, and 4 plus minus 1 is still 3. So it's not an issue which way around you do it here, but drawing it, you will need to draw obviously minus Q to make it make sense. Okay, so one more thing to have a look at, which is magnitude. So remember at the start I said vectors all to do with magnitude and direction. We've looked at what happens with directions. We haven't had a look at magnitudes yet. So here's a vector A. It says work out the magnitude of vector A. Now direction doesn't matter when working out the magnitude, because all we do is we use Pythagoras. So there's my right angle triangle starting from this point to this point. And remember with Pythagoras, I'm a massive fan of drawing the squares on either side. So if this is 3, obviously I need to work out the area of the square. So 3 squared is 9. And then this one here, the length there is 4. So the area of the square is 16. And then if you remember Pythagoras, if you don't, just have a quick look back through my video. You add the 2 smaller squares to get the area of the big one. So 9 plus 16 is 25. And then to find out the length, you square root the area, and then you get the answer of 5. And just a quick note, when we talk about magnitude, we tend to write it like this, where we say the magnitude, and we draw 2 lines either side of it, of A is 5. So we use Pythagoras to actually work out the magnitude of a vector. So that's using the drawing way, and I'll just do this one without drawing the drawing way. I'll just do it algebraically, just so you can see both ways, in case that way is a little bit confusing. So again, I want to work out the magnitude of B. So ordinarily we start from here, so I'm going to go across and then up. So I've made my right angle triangle. Now of course this would be technically, hang on, let's count this, 1, 2, 3, 4, 5, 6, 7, 8. So that would technically be minus 8 and 2. But like I said, direction doesn't matter here. And even when you use Pythagoras, 8 squared is 64, and minus 8 squared is also 64. So the negative here is actually irrelevant, but it's probably always a good idea to write minus 8, just so you always get in the habit of seeing left as negative. Okay, so the magnitude of B, remember that's our notation here, is going to be the square root of 2 squared plus minus 8. I'm going to put that in brackets to show it is minus 8 squared. Of course, that's the square root of 4 plus 64, which is the square root of 68. And it might ask you to leave it in that. It might ask you to leave it in surd form. But if you square root that, I believe you should have the answer of 8.2, and that's rounded to 1 decimal place. Okay, so you can just do it algebraically by looking at it like that, or as I say, using Pythagoras, using the diagrams like that. It depends on which method you've been taught or which you prefer, but obviously both work because you're just using Pythagoras to work out the magnitude. Okay, last thing we're going to have a look at now is how do we do all of that without any diagrams. So let's give that a go. So at the top here, I have some vectors. I'm told A is this one, B is this one, C is this one, and D is this one. And we're just going to very quickly go through how you work these out without any diagrams. Of course, you can draw a diagram, but you can do it quite quickly. So as we've mentioned before, 2a, just a scale factor. So 2, and then A is the vector 3, 2. So I just times the top. So 2 times 3 is 6, times the bottom, 2 times 2 is 4, and you're done. Minus 3, I know we had a look at 3b before, but it doesn't matter if it's a minus 3, we just treat it exactly the same. So minus 3, and then the vector b is 4, 1. Minus 3 times 4 is minus 12. Minus 3 times 1 is minus 3. So again, your negatives come into play a little bit here. A plus C, we saw this with a diagram, and we also saw how to do it without using a diagram, so just a little refresher. A is 3, 2. I'm going to add C, which is minus 2, 5. Add the tops, 3 add minus 2 is 1. Add the bottoms, 2 add 5 is 7. Remember, we had the minus D, so whatever D is, we basically times it by minus 1. All the signs change, so minus, and then D is minus 6, minus 4. Deliberately chose this one because these ones are already negative. So if that is D and you want minus D, change the signs or times everything by minus 1 if you prefer to think of it like that. Either way, minus D will be 6, 4. Okay, B minus C then. So B is 4, 1. Take away C, which is minus 2, 5. Need to be careful here. This is where people go wrong. 4, take away minus 2. So we're taking away a negative number, which means we add it. So 4 add 2 is 6. So be very careful that double negative there. And then 1 take away 5 leaves you with minus 4 like so. So just be careful with that double negative should it occur. And of course then you can combine them. So we can say we've got the 5 and then we've got A, which is 3, 2. I would always write this out as well, guys. Show the examiner you know what you're doing. And then 2b, which is 4, 1. It also helps you to prevent making mistakes. Then multiply it out because you get marks for that. 5 times 3 is 15. 5 times 2 is 10. And then we've got the next one. 2 4s are 8. 2 1s are 2. And then, of course, add the tops. 15 add 8 is 23. 10 add 2 is 12. And you're done. Same idea here. This time it's just got a negative, but not a problem. Just treat it exactly the same. So we've got minus 2, 5 is the vector for C, plus D, which is minus 6, minus 4. So I'm just going to expand this one first. Minus 2 times minus 2. Remember, a negative times a negative is a positive, so that's going to give me 4 and then 5. Oh, nope, sorry, I'm being silly, I'm trying to do too quick. Minus 2 times 5 is minus 10. So yeah, always take your time. And then of course we just keep our minus 6, minus 4 there. Add the top, 4 plus minus 6 is minus 2. Minus 10 plus minus 4 is minus 14. Okie dokie, nearly done. Next one, 3b, so 3 and then b is 4, 1. Take away 2 and then d is minus 6, minus 4. So times the top, 3 times 4 is 12. 3 times 1 is 3. 2 times, you have different ways here. You could do minus 2 times minus 6 and minus 2 times 4 and then add the results. Or you can just put the minus down here and treat that as a 2, which is what I'm going to do, and do 2 times minus 6, which is minus 12. 2 times minus 4, which is minus 8. And then you can take them away. I think that's probably the least confusing one to do. 12 take away minus 12, there's that double negative again, so 12 take away minus 12 turns into an add, so 12 add 12, 24. 3 take away minus 8, so again double negative, so it's actually 3 plus 8, which is 11. Okie dokie, big one now then. So let's take our time. We've got 2, and then A is 3, 2, plus 4, and B is 4, 1, minus 3C, and C is minus 2, 5, plus 5D, and D is minus 6, minus 4. So let's expand these out. 2 times 3 is 6, 2 times 2 is 4. 4 times 4 is 16, 4 times 1 is 4. Take away 3 times minus 2, which is minus 6. 3 times 5 is 15. 5 times minus 6 is minus 30. And then 5 times minus 4 is minus 20. So all we have to do now is just add the top. So 6 adds 16 is 22, minus, so that's our plus again, so that gives us 28. Then take away 30, leaves us with minus 2 on the top row. 4 add 4 is 8, take away 15, then add minus 20, so basically we're taking away another 20 as well. We'll leave you with minus 27 as your final result. So it looks horrible, but actually it's just a little bit of adding and subtracting. And finally, work out the magnitude of A and D. So again, no diagram here. I'm just told the vector. Of course, you can draw a diagram to help if you wish, but essentially, there's going to be one side, there's going to be the other side. So you can just quite simply do as we did in the second example and just go, okay, square root of 3 squared plus the square root of 2 squared, which is the square root of 9 plus 4. Which is the square root of 13, and again I believe to one decimal place that's 3.6. And same with this one here, the magnitude of D. Again, having the negatives doesn't matter, but I'll write them in. So minus 6 squared plus minus 4 squared. So minus 6 squared is just the same as 6 squared, which is 36. Minus 4 squared is just the same as 4 squared, which is 16. Add the two together to get the square root of 52, which again I believe to one decimal place is 7.2. So you can do obviously those the quick way without diagrams, but I do think it's worth seeing the diagrams to actually see what vectors, what does it actually mean. So that's an introduction, that's the basics of vectors, guys. So check out the next videos where we look at it with geometry, so within shapes, and then definitely check out the last video, which is some tricky stuff, proving lines are parallel and proving lines, two parallel lines are actually on a straight line. Thanks for watching, guys. Cheers.